We are given that f of x equals 1/2 x cubed plus 3x minus 4, and we're going to let h be the inverse function of f, and we're asked to find h prime of negative 14. And we're given that f of negative 2 is negative 14. So folks, here I have schematic versions of the original function and the inverse function. So they give us that f of negative 2 is negative 14. Therefore, we know that we have a point on f, negative 2, comma, negative 14. Now, when it says find the derivative of h of negative 14, this is the derivative of the inverse of f at negative 14. It's important to realize, folks, that they're talking about negative 14 on the inverse graph. Okay, so we're asked to find the derivative on h, which is the inverse of f, when the x value, when the input value on h is negative 14. Okay, so right away we recognize that these are sister points. If the output on the f function is negative 14, then the input on its inverse function, namely h, is negative 14. Therefore, we can go ahead and insert negative 2 here. In other words, when you have inverse functions, folks, recall that the x and y values swap. Okay, so now that we have this established and we're charged with finding the inverse here, we're charged with finding the slope here. We're charged with finding the derivative here. The inverse function, we don't have it. So we can't plug negative 14 into the derivative of h. So the game plan here, folks, is we're going to use the fact that the slopes at any given point of a function and its inverse are going to be reciprocal. So we're going to find the slope here on f, on this sister point, and then we're going to take the reciprocal, and that's going to be our answer. Okay, so what we're looking for here is f prime of negative 2 is going to equal something, and whatever that is, to get h prime at negative 14, we're going to take the reciprocal of whatever we get. Okay, so first thing is we got to find f prime and then plug in negative 2. So f prime, if we use the power rule, is going to be 3/2 x squared plus 3. And if we plug in negative 2 there, we're going to get positive 9. Therefore, h prime at negative 14 is going to be 1 over 9. Folks, one of the things that I find difficult with this topic are the various formulas that you'll see in a standard calculus textbook. So whatever formula you see, try to break it down into what we have here. Let's recall what we did to solve our previous problem. We have a function f and we have a function h. Sometimes I switched from capital to small letters. I apologize. But basically, we were charged with finding the derivative of the inverse function at negative 14. Now recall, that negative 14 refers to the input value, the x value on the h graph, on the inverse graph. Now, we don't have the equation of the h graph. If we did, we would just plug in negative 14 into the derivative of that function, but we don't have that. So what did we do? We recognized that the slope here on the inverse function and the slope here on the original f function are going to be reciprocals if indeed these are inverse functions. So we switched our focus into finding the derivative here, the slope of the tangent line here, where we had the equation. And we recognize that if these are sister points, which we determined because they told us f of negative 2 is negative 14, then we could find the slope here by plugging negative 2 into f prime, getting that slope, and the reciprocal would be our answer. So look at what we did here. To find the derivative at negative 14 on the inverse graph, we took the reciprocal of f prime at -2. So that's what this is saying, this general formula. To find the derivative at a point x on the inverse function, okay, so that would be here. Let's call that x. If that's x, this is h of x. Okay, to find that derivative there, you have to go to f, get f prime, and plug in h of x. And that's exactly what we did. We went to f, we got f prime, and we plugged in h of x. What was h of x? None other than -2. So keep it in mind. If you want to find the inverse, if you want to find the derivative on the inverse function at a point x, you need the output on the inverse function, h of x. Then you go to f, you take the derivative, and you plug the output from the h function into the derivative of the f function. Okay, folks, I had the instructions all typed out. If you want to take a screenshot of that, go right ahead. To find the derivative at a point x on the inverse function, so right here, point x on the inverse function, to find its derivative, h is the inverse function, we're finding the derivative. We're finding the slope of the tangent line on the inverse function at a point x, at an input of x. To do that, you must first find the output on the inverse function. That's going to be h of x. You then take the output of the inverse function, which is h of x. So in our previous problem, that was -2. Okay, right there, -2. And then you plug that in to the derivative of the original function. Typically, we have the original function. That allows us to take the derivative of it. And when we do that, we take this h of x, which is then going to become the input on the f graph. We plug that value into f prime, and whatever value we get, in the previous example we got 9, that will go into the denominator of your answer. So we put that 9 right there, and our final answer was 1/9. Folks, we mentioned at the outset that one of the difficult parts of this topic is the various formulas that you're going to see. I would argue that any formula you see can be broken down into what we have here. Recall what we have here. We have f and h are inverse functions. We have a point on h with an input of x and an output h of x. We take that output and we plug it into f prime because they're going to give us the f function. Whatever result we get, we put that into the denominator of our final answer, and that gives us the derivative at x of the inverse function. Okay, here we go. Look how they rewrite it here. This f -1 is the same thing as our h. Okay, so the derivative of the inverse function of f at a point A equals this. Now, what does this equal? Well, at a point A, see how these a's match just like our x's match? So this would be the output of the inverse function if you plug in a. That's the same thing as h of x. And what did they do here? They plug that value into f prime. So these equations, these formulas are synonymous. Just remember that this value, just remember this value is the output on the inverse function. The output on the inverse function. And once you have the output on the inverse function, you're going to plug that into f prime. That's what this means, f prime of this. It means taking the output on the inverse function, otherwise known as h of x. Here it is, h of x, the output on the inverse function, and plugging that into f prime. F prime of the output on the inverse function. Okay, folks, here's another way you'll see the formula written, with the ddx operator applied to the inverse function. This is no different than this shown here, which is the derivative of the inverse function. This is the derivative of the inverse function. And look what they have here. They have the output on the inverse function right here. This is, if you take f-1 of x, this is saying you're plugging in x to the inverse function and you're getting an output. So this is the output of the inverse function. And what are they doing with that? They're plugging it into the derivative of f. Same thing we're doing here. Here's the output on the inverse function. X, you plug that in, you get h of x. We take that output, we plug it into the derivative of the original function. That's what they're doing here. Same thing. Folks, here's yet another way you're going to see this written. You're going to see the derivative of the inverse function is 1 over f prime of y. But you have to remember, that y is the output on the inverse function, or of the inverse function, when you input x. So that scenario would be, you have an f here, and you have an inverse here. Sometimes they'll call this g as an inverse. And on g, there's going to be a point x comma y, where g of x equals y. That output on the inverse function is what's getting plugged into the derivative. Just keep that in mind. Just keep going back to that the output on the inverse function, whatever they call it, whether they call it y or however they refer to the output of the inverse function, that goes into the derivative of the f function. And again, remember, your answer is in the denominator. Let's now do some examples. We have f equaling 6x to the 5th minus 7, and I'd like to focus here on part B. We're asked to find f inverse of 2 and f inverse prime of 2. Okay, they want the derivative of the inverse at x equals 2 for part 2 of problem B. Okay, so there's two ways to get f inverse of 2. We could find the inverse and then plug in 2, but sometimes we're going to get very difficult problems to find the inverse. So we're going to do it a different way. So here's our two functions. We have our function f here, and we have the inverse function here. Now I'm going to call this g. Actually, I'm going to call it h. That's our inverse function right there. Okay, so what they want is f inverse of 2. So that means we're going to have an input of 2 on the inverse function. Now, they want this value. Okay, we don't know what that is because we don't have the inverse function. But here's what we do know. We know f equals 6x to the 5th minus 7, and we know that on f, since these are sister points, the output is going to be 2 and the input is going to be the value that we want. So what are we going to do here? Well, if we know we want the output to be 2, we're going to set f function equal to 2. So let's do that. 6x to the 5th minus 7 equals 2. 6x to the 5th equals 2 plus 7, which is 9. X to the 5th equals 9 over 6. X to the 5th equals 3 over 2. Therefore, x equals the 5th root of 3 halves. Folks, if that equals our x value right there, the fifth root of 3/2. That's the same thing as plugging 2 into our inverse function, and we get the same result. They are sister points. So this is the answer to the first question. Next, we are asked to find the derivative of the inverse function when the input value is 2. So they want the slope of the tangent line right there. Okay, folks, we're going to use this formula. Remember, h is the same thing as the inverse function. They want the derivative of the inverse function, so they want h prime of 2. So we're going to remember that's going to be 1 over f prime of the output at x equals 2. Okay, this is h of 2. Okay, so what is h of 2? H of 2 is this value here, which is the fifth root of 3 over 2. So the game plan here is to get this answer, we're going to plug this value into f prime, and whatever we get, that's going to be the denominator of our answer. Okay, so f prime, we have f. F prime, if we use the power rule, is going to be 30x to the fourth. So we're going to do f prime of the fifth root of 3 over 2. So we're going to end up with 30 times the fifth root of 3 over 2 to the fourth power. And for simplicity, we're just going to leave our answer like so. So our final answer is going to be that h prime of 2, or f inverse prime of 2, is just equal to 1 over 30 times the fifth root of 3 over 2 raised to the fourth power. Next, we are given this function, f equals 1 over x, and we're asked to find f inverse of 2, excuse me, and f inverse prime of 2, the derivative of the inverse at 2. So I'm going to rewrite this as h of 2 and h prime of 2, knowing that h prime is the inverse of f. Okay, and I'm going to keep this little diagram and this formula in my mind, that the h prime of x, the inverse, the derivative of the inverse at a point x on the inverse, is 1 over the output plugged into f prime. Okay, now let's first do this one, which really doesn't involve our formula. And recall that if we have two functions, f and h, remember h is the same as the inverse of x, and they want to know what f inverse of 2 is. That means they want to know what the output is on the inverse function when they want to know what the output on the inverse function is when the input is 2. So we don't know that yet. And on f, we know that these coordinates are going to get reversed. So we have to ask ourselves what input value on f would result in an output value of 2. Because if we can get that, then we will be able to answer our question. So to get the input value that yields 2 as an output, we're going to set 1 over x equal to 2. And x is none other than 1/4. So if x is 1/4, x is 1/2. So if x is 1/2 here, we're going to take out that question mark and change it to 1/2. And then the output on the inverse function h becomes 1/2. So the answer to this part is 1/2. Now that we found h of 2, we found f inverse of 2, let's switch gears and find the derivative of the inverse function at x equals 2. So recall, here's our formula. The derivative of the inverse function at x equals 2 is 1 over h of x plugged in to f prime. Okay, so to do this, we need to find f prime. And if we take f equals 1 over x, and we change that to x to the negative first, then f prime is going to equal negative x to the negative 2, or negative 1 over x squared. So that's our f prime. We're going to take our h of x and plug that into f prime. We're going to have negative 1 over 1 half squared, negative 1 over 1/4 equals negative 4. Now, folks, that represents this denominator. So the final answer for what is the derivative of the inverse at x equals 2 on the inverse is going to be 1 over negative 4, otherwise known as negative 1/4. Next, we are told that f of 2 equals 9, f prime of 2 equals 6, f of 7 equals 2, f prime of 7 equals 8. Find g prime of 2 considering the fact that g and f are inverse functions. So let's do a schematic where we have inverse functions. So folks, it looks like they're giving us 2 points here. First they tell us f of 2 is 9. Let's label this f and this g, and recall g is the inverse of x. Okay, so at this first point, we'll call it point A on f. If you input 2, you get 9. That means this point is 2 comma 9. And they tell us the derivative when x equals 2 is 6. So the slope of the tangent line here, like point A, is going to be 6. Okay, then they give us a separate point, B here. And they tell us that when you input 7 into f, you get 2. So that means this point is 7 comma 2. And then they tell us that at x equals 7, if you do f prime, the slope of that line, tangent line, would be 8. Okay, now they want us to find g prime of 2, considering they are inverse functions. All right, so if they want g prime of 2, that means the input on g is going to be 2. So which of these points are we going to use? If the input of g is 2, that's going to match with an output of f that is 2. So therefore, we're going to be sister points with point B. So I'm going to come over here, and I'm going to use the same color, and I'm going to call that sister point, B sister. Okay. So they want the slope of this line right there. Now the output on G is going to be 7, but we really don't need that. We're just trying to get the slope of that line. Well, folks, if these are sister points and these are inverses, these graphs are inverses, then the slopes are reciprocal at the inverse point. So the answer to this question, g prime of 2, is going to be the reciprocal of the sister point slope, none other than 1 over 8. Next, we are given that f of x equals e to the 3x, and we are asked to find the derivative of the inverse at a point x. The derivative of the inverse at a point x. So let's go ahead and create our schematic functions. We have f here, f equals e to the 3x, and then we have the inverse function here, f to the negative 1 of x, and I'm going to call that h of x. Okay, so to find the derivative at the inverse function at a point x, that's the same thing as finding h prime at x is going to equal 1 over f prime of h of x. Okay, so we have a point on the inverse graph where x is the input and h of x is the output. So we need to plug this value into f prime. Now, we don't have that value, but we know the sister point here is going to be h of x, comma, x. All right, so that means we need to find what input value into f would result in that output value. So we're going to say e to the 3x equals x. And we're going to find the input value of x that we're going to put right here. Okay, so let's take the natural log of both sides. Since this is the base e, when the base of the log matches the base of the argument, we can cancel and we're left with the exponent. Excuse me. So we have 3x equals ln of x equals ln of x over 3. Okay, so we can recalibrate over here and change this. Instead of h of x, the input is ln of x over 3. And we can put it over here on our inverse graph as well, just to emphasize these are sister points. Okay, folks, the goal of this question is to find the slope of the tangent line here, but our plan now is to find the slope of the tangent line here, and then we're going to take the reciprocal, and that's going to be our answer. Okay, so we need to find f prime. F prime is going to be 3e to the 3x. That's f prime. We're going to take f prime of ln of x over 3. So that means we're going to have 3e to the 3 times ln x over 3. That's going to equal 3 e to the ln of x. This is going to cancel out, and we're going to end up with 3x. Okay, so this value is 3x. Therefore, h prime of x, or f inverse of x, is going to end up being, here in yellow, 1 over 3x. So that is the final answer to this problem. Next, we are told that g and f are inverses, and they want us to calculate g prime of 1, and f is given here. So let's go ahead and put f over here. F of x equals x plus e to the x. And there's going to be a point here with an input and an output. And let's put g of x over here, that they are inverses. You can also write this as f inverse of x. And there's going to be two coordinates here. And these are sister points. And they want us to calculate g prime at 1. That means when the g value is 1, when the inverse function has an input of 1, they want to know the derivative there. That means they want to know the slope of that line. So folks, the whole key is to get the slope of this line. And once we get the slope of that line, we can just take the inverse of it. Now, that's the simplistic way to think about it, but they also will throw fancy formulas at you. You will see as follows. You will see that the derivative at a point x on the g graph equals 1 over f prime of g of x. G of x, folks, is right there. That's the output when you plug in 1 into the g function. So it turns out this value, whatever that is going to show up here on f, and we're going to take f prime of that value, f prime of this value. And whatever we get is going to go into the denominator of our answer. Okay, so now how do we get that box? That's what we need, because once we have that, we're going to plug that into f prime. And whatever we get is going to go into the denominator. Okay, how do we get that? Well, we utilize the fact that if 1 is the input on g, then 1 is the output on f. So we have to set f, which is x plus e to the x, to this output. We need to determine what x value that when we plug into f yields 1 as an output. Now, folks, this is hard to solve, and really the only way to solve this is by inspection. So we see that if x equals 0 and you have 0 plus e to the 0, this is going to be 1, and that x has to be 0. So let's go ahead and replace that golden box with 0. Okay. What we have left is to take the derivative of f and plug in 0. So let's do that. So we want to get f prime is going to equal 1 plus e to the x. F prime of 0 is going to equal 1 plus e to the 0, which equals 2. Therefore, to get our answer, we have to put this in the denominator. Another way to think of it is, we just found the slope on the f function when the input at f is 0. When the input of f is 0, the output's 1. That matches an input of 1 on the inverse function. We found this slope to be 2. Therefore, the slope here at the sister point is going to be 1/2. So whether you think of it in terms of these lines being reciprocals or using the fancy formula where we're going to plug that into the denominator, we're going to get the same answer. That the derivative when x is 1 on the g function is 1/2. Next, we are asked to find g prime at -1/2, where g is the inverse of f, and here is f. So we're trying to find the derivative of the inverse at x equals -1/2 on the inverse. So here we have our two functions. Here's f equals x cubed over x squared plus 1. And we're going to have a point here, something comma something, and there's going to be a sister point on the inverse g. Now they want to know g prime at -1/2. They want to know the slope of the tangent line when the input on g is -1/2. Well, that is tantamount to having the output of -1/2 on f. So our goal, folks, is to find this value, which is the same as this value. This value is g of -1/2. This value is the inverse of -1/2. Okay, so how do we get that? Well, we set the f function equal to that output and we solve for x. So we set this to -1/2, and you're going to get a polynomial, folks, and you have to use a calculator for this. So you'll have to trust me that you're going to get x equals -1, and then you're going to get a couple of imaginary roots. So we're going to go with x equals -1 in the interest of time. So we're going to put that as the input of x that yields -1/2 as an output. So that's going to come down here as well. Okay, so there's two ways to approach this. You could think of it as just getting the tangent line on F and then taking the reciprocal, and that'll give us our answer. That'll give us the derivative on G. It'll give us the slope of the tangent line on G. So how do we get the slope of this orange line on F at x equals 1? Well, we do f prime of negative 1. And when you do that, I'm not going to bother taking that derivative and plugging in negative 1. I'm just going to tell you the answer is 1. So it turns out the slope of that orange line on F when that input is negative 1 is 1. Therefore, this is also going to be 1. So in the end analysis, g prime of negative 1 half is going to equal 1. Now again, folks, you'll see this in fancy formulas. And the formulas all come down to putting this output on the inverse function into the derivative. All the formulas have it like so. They have f prime of the output on the inverse graph. So some of them will have g of x. Some of them will have an inverse of x. So in this case, these would both be negative 1 half. So you have to decide whether you want to go formula route or just visual route, but the idea is the same. The whole key is to get this value right here. Once you have that value, you can either A, put it in the formula, because that value is the same as that value, either put it in the formula, or use this to get the derivative at that point, and then take the reciprocal. All right, I just want to make this formula a little neater here. This formula is the derivative at x equals 1 over f prime of f negative 1 of x. Okay, let's look at equation 1. It says that the derivative of the inverse function with x as an input on the inverse function is 1 over f prime of the output on the inverse function. Let's first remind ourselves that the derivative at this point on the f function, the slope of the tangent line at that point on the f function, and the slope of this tangent line on the sister point are reciprocals. Look, the reciprocal is set up right here. Okay, so what this formula is saying is that the output on the inverse graph, right there, if you plug that into the derivative of f, then you get the slope. You get the derivative at f prime of x. So in other words, to get the slope of this line, we would have to take the derivative of the x value. What is the x value here? What is the input value here? None other than the output value on the inverse function. So if you take f prime of this, you're going to get the slope at the blue line, and then to get the slope on the red line, you just take the reciprocal. This here is the output on the inverse graph. Folks, this is equation 2, and in my opinion, this is the best one. You could also have this as G. The important thing to remember is that F and H are inverses. Okay, so they're asking us for the derivative of at a point x on the inverse function. They want to know if that is your point x. They want to know the slope of that tangent line. So how do we do that? The first thing we do is we get h of x. We get the output on the inverse graph. This is the all-important value, right? there. Why is that all important? Because we can come to f, because that h of x becomes the input on f. We could come to f. We could take the derivative of f. We could plug that value into the derivative of f. That gives us the slope of f. And to get the slope of h, we take the reciprocal. Okay, so again, the derivative at a point x on the inverse graph is found by taking h of x, the output right here, the output on h of x, and plugging it in to f prime at the sister point, right there. That's the input. Plug that in to f prime. That gets us the derivative at f, and we take the reciprocal to get it at h. Okay, here's equation 3, where they're introducing the ddx operator. So they're saying that we're taking the derivative of the inverse function at a point x. And they're telling us that this equals 1 over the y value plugged into f prime. Folks, it's as if they're trying to make it complicated. So here's what they're saying. They're saying that x is the input on the inverse function right there. Y is the output on the inverse function. And you're going to take the y value on the inverse function, the output on the inverse function, and you're going to plug that in to the f prime equation. And whatever you get here is going to be in the denominator. Okay, so that's tantamount to having this y value here and taking the derivative, f prime, getting f prime of y, because that will be the input. F prime of y will then give you the slope of that line, and to get the slope of this blue line, we take the reciprocal. Again, the output on the inverse graph gets plugged into the derivative of f, and that value is in the denominator. All these formulas are the same. Folks, just when you thought we had it figured out, here comes another equation. They're saying that the derivative of the inverse at point A is 1 over f prime of b. So now they're introducing a and b. But don't be intimidated. It's all the same. Okay? What they're saying is, if that's f and that's f prime, if that's f and that's f inverse, they want the slope of that line. They want the derivative at point A on the inverse. That's what this says. The derivative on the inverse function with an input of A. Now, the output of the inverse function is B. So what are we doing? We're taking the output of the inverse function at that point A, that input A on the inverse function. We're taking that output, and what are we doing with it? We're plugging it into f prime. And whatever we get is in the denominator of our answer. So here, if we recognize that this B is now going to become the input at A, if we get f prime of B, that's going to give us that slope, and to move to that graph, we take the derivative. This is simple as well. I like this formula as well.